topic is Hall effect, rotary position sensor.
Yeah. My name is Ebi Goudarzi, and I'm master student in second semester in CHEMNITZ University of Technology. And my topic of my presentation is Hall effect, rotary position sensor IC. And here we can see the table of contents. I will give you an overview of rotary position sensor, two types, contact one and non-contact one. And then I'm going to give you an introduction about a very specific type of Hall effect rotary position sensor IC. And then I will be more specific, and I will go a little bit through the details of working principle of Hall effect rotary position sensor IC. And then I will mention some application, actually some common application of such sensor in automotive and then references. And here you can see actually first I've shown in this slide a contact rotary position sensor, a contact one I mean. Contact one is based on potentiometer, and it's somehow old-fashioned to measure the position. And potentiometer is a device that its resistance will change according to the change of angle due to the rotation. And in this, in this graph, you can see a very simple graph. This is a very simple graph, and this is the relation between output as voltage and input as a rotational angle due to rotation. And this is the potentiometer. And here we can see some common applications. And as you can see, these are the analog displays, and they are somehow old, and they've been already replaced with digital ones, new ones. And here, actually, drawbacks of potentiometer launched many developments toward non-contact rotary position sensor. Because there is contact in a contact rotary position sensor, a friction will be created, and that will lead to mechanical louding or electrical noise or wear or misalignment or such problems. And such problems can be avoided. And such problems can be avoided with non-contact rotary position sensor. And for replacing non-contact rotary position sensor, we can use three principles: Hall effect, magnoresistive, and inductive. And I've been interested in Hall effect, and I'm going to go through the details of Hall effect. And here, first of all, I would like to mention some facts about such sensor. As I mentioned, Hall effect rotary position sensor IC is a very specific kind of non-contact rotary position sensor. And such IC is manufactured with CMOS technology, and they can be thinner and thinner, and they can be miniaturized. And here it's an IC, and this IC, and the function of this IC is to measure the Hall effect. And these yellow parts are IMC, and IMC is abbreviation responsible for integrated magnetic concentrator. And the function of these yellow parts, I mean IMC, is to amplify the Hall effect. Actually, the function is to help the IC to measure the Hall effect more remarkable and more easier. And I would like to introduce IMC. IMC is a ferromagnetic layer. You've already passed material course, and there ferromagnetic can be a giant resistive magnetic, and they can be created also with CMOS technology. And here is again a very simple graph. As you can see, a relation between output and input. And as you can see, this conductor, this conductor, if you apply current through this conductor, a magnetic field will be created around the IC here. And as you can see, input as current or magnetic field, or output as voltage. And here, Hall effect. What is Hall effect? Okay, if we have a loaded piece of silicon, this blue part, and it's called Hall Planner. And if we apply current into X direction, and if we, at the same time, if we apply, and if we expose, actually, if we expose this value part, I mean load of silicon, into a magnetic field in Z direction, then a Hall voltage will be created in Y direction. And this is the responsible formula for that. And actually the main idea, or the main point here is that V Hall depends on flux density, flux magnetic density. And this is the idea behind creating or designing Hall effect rotary position sensor IC. And with the help of this picture, we can understand the principles of such sensor or such ICs. Here, this pack is the IC, this whole pack, and these blue parts are Hall planners for measuring Hall effect, and this yellow part is IMC for amplifying the Hall effect. And as you can see, the concentration of magnetic field here and here is different. And if we change the position of the IC, according to that Hall formula, the concentration of magnetic field being exposed to the IC will change. And from that formula, we can easily, according to that formula, Hall voltage will change, and from there we can easily calculate the change of the position. And the key idea is to mount such IC on a rotor. And when the rotor spins, and at the same time, if we expose the rotor to a magnetic field, and when the rotor spins, the position actually of the IC will change with respect to the concentration of a magnetic field. Then, with that formula, we can easily measure the change of the position of the IC. And here, as you can see, with help of such IC, we can remove mechanical connections and movable parts in a car. And with help of such IC, we can create a steering wheel position sensor, non-contact steering wheel, or non-contact joystick. And the idea is really simple. We can easily mount such ICs on movable parts, and then we can remove mechanical connections. It's really easy. But the principle is somehow complex. And this is my references, and thank you for your attention and your time.
Okay, thank you very much for your contribution. Well, let's start with the content of this talk. Let's analyze the content.
Now the content was good.